In this video, we are going to get an introduction into square roots. Now, one thing I do want to point out, actually, before I get started, is this is not section 5.7. I made a typo when I was making the notes. This is actually section 5.6. So, okay, now let's get started. So let's read through the introduction. So far, we know that the opposite of addition is subtraction. And we also know that the opposite of multiplication is division. But have you ever thought about what is the opposite of something squared? The answer to that is something known as a square root. Square roots are the opposites of something squared. So let's highlight that because that is important. Square roots are the opposite of something squared. So, with that being said, since we know a square root is the opposite of something squared, let's think through our first problem of a square root. So, if we know that 4 is squared, that means 4 times 4. 4 times 4 is 16. So, if 4 times 4, or 4 squared, is 16, what do we think the square root of 16 would be? I encourage you to pause the video and try to think this out on your own. And assuming you have given this a shot, let's work through it. So since we know that the square root of something squared is the opposite operation, and we know that 4 squared equals 16, so the square root of 16 would equal the square root of 4 squared. And we know, since we know that square roots are the opposite of something squared, this exponent of 2 and the square root here cancels out. And we're just left with 4. And that is our answer. So with that being said, let's practice some more with this idea. So we have the square root of 4. Now, when you solve square roots, you have to think, what number do I square to get to 4? So we have this question squared, this question number. Here, let me write this. What number squared equals 4? And if you're thinking 2 squared equals 4, you are correct. Since 2 squared equals 4, the square root of 4 is 2. Because 2 squared equals 4, so therefore the square root of 4 is 2. Now looking at example 2, I encourage you to pause the video and try this on your own. And assuming you have worked through this, let's think about this together. So I'm going to say here, actually instead of saying equals, let's draw an arrow and say what squared equals 5? I mean, not 5, my apologies. What squared equals 25? So what do we have to square to get to 25? If you're thinking we have to square 5 to get to 25, you are correct. So, let me write this here. This question equals 5. So, therefore, if we have to square 5 to get to 25, the square root of 25 is 5. Now, looking at example 3, I encourage you, actually, because we got a little bit gone through a couple of problems, I encourage you to go through all these problems on your own if you can. Problems 3 through 6. And assuming you have tried those problems on your own, let's work through this. So, to find out what the square root of 1 is, we have to think, what squared equals 1? And if you're thinking 1 squared equals 1, you are correct. So since 1 squared equals 1, the square root of 1 is 1 because 1 squared is 1. Now square root of 36. We have to think what squared equals 36. And that is 6 squared equals 36. Because 6 times 6 is 36. So the square root of 36 equals 6. Now, for 81, what squared equals 81? And 9 squared happens to equal 81. So the square root of 81 equals 9. Last but not least, we have 64. So what squared equals 64? And in this case, 8 squared equals 64. So therefore, the square root of 64 equals 8. Okay. So now that we have worked through those problems, one thing that I'm introducing as well in this section is that not every square root will have a perfect number like we did in this section above. So let's first off use what we have, our knowledge from this section above, to estimate some square roots by hand. So what we did above are examples of what's known as perfect squares. And you don't have to know the definition, I would say. It's definitely useful to know. Actually, I would know what perfect squares means. And perfect squares, essentially what it means is when you have a number that has, when you take it, this number under square root, a perfect square is basically when you have a square root of a number and you get out a perfect whole number like this. Now, with that being said, let's work through these examples. Now, I'm going to walk us through example 1, and then once we get through example 1, I'm going to encourage you to pause the video and do examples 2 through 4 once we finish example 1 and you see the process of how to think through this through. So example 1, we have to think what two perfect squares is the square root of 8 between. So let's first write this out. So we know that the square root of 4 equals 2. And then the next perfect square would be 3 squared, and 3 squared is the square root of 9. So we know the square root of 4 is 2, and the square root of 9 is 3. So since the square root of 4 and the square root of 9 is between the value of square root of 8, or 4 and 9 is between the value of 8, we can guess what the value of square root of 8 is based off that. So we are going to approximate to the nearest tenths place. The nearest tenths place, if you don't know, is the first decimal place. So looking at the square root of 8, we can estimate it because, well, let's think about this. The square root of 8 is closer to 9, a lot closer to 9 than it is to the square root of 4. So since the square root of 8 is so close to the square root of 9, let's just say that the square root of 8 is about 2.9. You could also maybe say, or 2.8 maybe. So we're just guessing, right? It doesn't have to be perfect, but we're just using our knowledge from what we have in the sections above, or the first parts. So using that, I encourage you to pause the video and just think through examples 2 through 4, because these are the last examples we have in this section. So assuming you have thought this through, let's work through example 2. So we have the square root of 2. So we know that the square root of 1 equals 1. And we also know the square root of 4 equals 2. So with that knowledge, we can approximate the square root of 2. And I would say, because the square root of 2 is closer to 1 than it is to 4, I would say the square root of 2 maybe is 1.3. And I said 1.3 because the difference between 1 and 4 is only 3. So there's not too much of a large difference between these two values. So that's why I said 0.3. So as long as you get around 1.3 as your guess, you're good to go for the correctness on this one. Now let's look at the square root of 22. We know that the square root of 16, or 4 squared is 16, so the square root of 16 is 4, and that 5 squared is 25, so the square root of 25 is 5. So with that knowledge, let's approximate the square root of 22. So 22 is closer to 25. So let's just say approximately around 4.7. And now let's look at our last example, example 4. We have the square root of 50. So with this, we know that 7 squared equals 49. So the square root of 49 is 7. And we also know that 8 squared is 64. So the square root of 64 is 8. So if we approximate square root of 50, well, square root of 50 is really close to the square root of 49. So since it's so close to the square root of 49, I would say this is approximately about 7 actually, because even if we were to find the perfect value for this, square root of 49, if we rounded to the nearest tenths, it would just round back down to 7 because it's so close. But if you said 7.1, I'll also accept that. The biggest thing here is just to understand that the biggest thing is to understand that you won't always have perfect roots or perfect squares like we did originally. And that to understand that all square roots have a value, or all square roots are numbers. So the last thing I want to do to end this section, let's practice putting these square roots that we did here into the calculator to see how close we got. So we're going to actually find actual estimations, see if we got somewhat near the actual values of this. So if you have a calculator, I encourage you to pause the video and get your calculator out. And to put square roots into a calculator, you should have a button that says second or 2. So you should have a button that looks like this. Oops, let me get this out. Here, let me write out steps. Calculator. Here, actually, evaluating square roots in calculator. So our first step is to press the second button. So when you do that, you're going to press second, and then you should have a button where you have where it says x squared. So you're going to press this second button, and then you're going to press this x squared button, and then from there, you're going to put the value. And you'll usually see some parentheses, so you're going to want to close those parentheses as well. Okay, so now let's put that in practice with example 1. So we have the square root of 8, so we're going to press the second button, and then we're going to find where x squared is. We're going to press that, and then we're going to put in the number 8. And then for me, I need to put close parentheses, or I need to put a second parentheses to close it, and then we're going to click enter. And for me, for the calculator, it says that the square root of 8 is 2.82. And now if we round that to the nearest tenth, that's going to be 2.8. So we actually got it exactly just by estimating. And the square root of 2, if we evaluate that, let's put that in our calculator. Oops, right calc. And our calculator says that is approximately 1.41, and then rounding 1.4. Now, I guess 1.3, but that was close. And then looking at example 3, we guessed 4.7. Let's see how close we were. So putting that in our calculator, I'm going to press second, x squared, 22, close the parenthesis, and you should get approximately 4.69. And 4.69 rounded to the nearest tenth is 4.7. So we got right on this one. And then looking at our last example, square root of 50, and the calculator, let's quick second, x squared, 50, close parenthesis, you get approximately 7.07. And then rounding that, 7.07 to the nearest tenths place, 7.1. So actually, before when I was explaining that this would just be 7, I was actually incorrect. So, my apologies. See, we can't always get exact, actually, with approximating square roots. But just the idea of being able to approximate them by hand is very important to understanding square roots. So anyways, thank you, and I can't wait to see you for the next section.